Okay, we're going to talk on the lymphatic system. I encourage you to read the text. It's fairly straightforward. I'm just going to make a few comments as we go along with this. The lymphatic system is part of your immune system. Remember, one of my first modules is the immune system, which we consider consists of the white blood cells, the lymphatic system, and the immune chapter. Okay, the lymphatic system is a system. So therefore it's composed of organs and cells and so forth. So it's composed of lymphoid cells, tissues, organs, and vessels we'll talk about. The three functions of the lymphatic system, primarily, one is to fight infection, and that's why it's part of the immune system. The other is to carry lipids from the GI tract to the bloodstream. So lipid-soluble things in your diet that you absorb in the small intestine are carried first to the lymphatic system and then ultimately to the bloodstream. Water-soluble stuff, like your carbohydrates and your amino acids, are absorbed directly into the bloodstream. So again, lipids have a circuitous route, first into the lymphatics, then ultimately into the bloodstream, as we'll talk about. The other thing is that fluids that come out of the bloodstream in something called capillaries must be returned in that area. If too much fluid comes out and doesn't return, then you have edema. If too little comes out and more goes back in, you have dehydration. So the lymphatic vessels help return some of the fluid. We'll learn that more when we get into the cardiovascular. But if for some reason there's a compression of the lymphatics, you get a condition called lymphedema. There are many reasons for edema, but if it's due to the lymphatic problem, it's called lymphedema. So those are the three functions: fight infection, carry lipids into the bloodstream from your digestive tract, and return fluid. Here's the lymphatic system here that you can see, and you can look at that in the text. I wanted to show you, here's the inside of your small intestine. So essentially, lipids would be floating down. This would be the lumen, and then they would go through the intestinal epithelial cells into that green thing drawn there, known as the lymphatics. And then ultimately, the lymphatics later return into the bloodstream. Okay, we go a little further. This was a schematic to show you the picking up of material into the lymphatics and then ultimately pumping until it returns and enters the bloodstream. It's a little schematic there. Fluid exchange between the cardiovascular. This is to discuss the fact that extra fluid is taken back into the bloodstream using the lymphatics. So the lymphatic system and the cardiovascular system are indelibly tied together for several different reasons. The cells that you find and the fibers that you find in the lymphatic system, well, obviously you'll find lymphocytes. That's the major ones. Then you'll find macrophages. Remember, macrophages are large cells, you remember, that do phagocytosis. You have some other cells called dendritic cells. A dendritic cell has multiple fingers to it. And some of these dendritic cells are called antigen-presenting cells. And antigen-presenting cells present to a T helper cell, the cell that is lost in AIDS. But we'll discuss that when we get to the immune system. So dendritic cells, reticular cells. Reticulose means thready. So these are very thin, thready cells. And reticular cells are special fibroblasts that secrete reticular fibers. Remember ANP1, the three types of fibers you have in connective tissue are collagen, elastic, and reticular. Reticular fibers are very delicate fibers. Collagen fibers for strength, elastic fibers for elasticity. Lymph is considered to be a connective tissue. Lymphoid tissues. Lymphoid tissues are an accumulation of lymphoid cells. So accumulation of lymphocytes forms a tissue. Accumulation of lymphocytes forms a tissue. The two types of tissues that you have are lymph follicles. Lymph follicles are a cluster of certain lymphocytes known as B lymphocytes that we'll discuss. So a lymph follicle is a cluster of B lymphocytes. Then you have diffuse lymphoid tissue. So unlike the lymph follicle, which is like a cluster of lymphoid cells, the diffuse are spread out. Now they're spread out in areas, in pipes we'll say, where you really meet the outside world more. One is the digestive tract. When food is not clean, so when it comes in, you want to clean it up. So in the wall of the digestive tract, you would find many different lymphocytes. The other is when you breathe in air. Okay? So both of these kind are associated with a mucous membrane. You remember, a mucous membrane opens to the outside world. And the two under mucous membrane, which are called MALT, mucosal associated lymphoid tissue, is GALT, gut associated lymphoid tissue, and BALT, bronchial associated lymphoid tissue. Okay, we go a little further. A lymphoid organ. What's the difference between a lymphoid tissue and an organ? An organ must have a partial or complete connective tissue capsule around it. Let me say that again. A lymphoid organ must have a partial or complete connective tissue capsule around it. When we look at lymphoid organs, we separate them into two groups, the primary lymphoid organs and the secondary. The primary lymphoid organs are where lymphocytes obtain immunocompetence that we'll talk about in the immune chapter. But immunocompetence is basically, let's say, an educational purpose, educational activity for newly developed lymphocytes. The two areas, or the two organs that are the primary lymphoid organ, is the bone marrow and the thymus. Those lymphocytes educated in the bone marrow, we'll learn later, are called B lymphocytes. Those lymphocytes educated in the thymus gland are called T lymphocytes. So the two types we have are B and T lymphocytes. There is another one that doesn't get educated, known as a natural killer cell, which is a lymphocyte. But we're concentrating now on the B lymphocytes and the T lymphocytes. Okay? The secondary lymphoid organs, like the thymus gland, the spleen, and so forth like that, are where educated lymphocytes go to do their job. So just like you're in college, you'll obtain a college degree, then you'll go from the college and find a job. Well, the primary lymphoid organs educate, and then the second lymphoid organs receive, shall we say, the graduated lymphocytes. Okay? The lymphatic vessels basically start as lymphatic capillaries. Then the capillaries coalesce together. Several of them come together to form collecting vessels. Then several collecting vessels come together to form lymphatic trunks. And then several lymphatic trunks come together to form lymphatic ducts. It is the two ducts where lymphatic activity, where lymph will enter into the bloodstream. So material is picked up by the lymphatic capillaries, goes to collecting vessels, then goes to lymphatic trunks, and then ultimately to the lymphatic ducts, where there are two of them, and then enters the bloodstream. Okay? The lymphatic flow is a one-way flow. Now, blood circulation, we'll learn, is in a circle. It's a continuous loop. Lymphatic flow is like a cul-de-sac in your neighborhood. It goes in one direction. So the material would be picked up in lymphatic capillaries, sucked from the connective tissue, then go to lymphatic collecting vessels, then to lymphatic trunks, and then to lymphatic ducts, and then ultimately from the ducts into the bloodstream. Okay? Lymphatic capillaries are very similar to blood capillaries, except they are more permeable. Permeable means wider open, that they can let things in more. They have loosely joined endothelial cells. An endothelial cell is a lining cell for blood vessels and capillaries. And the way the endothelial cells are set up, they kind of overlap. And one of the reasons for overlapping is to allow material from the connective tissue to come into the lymphatic and not exit it. So therefore, the pressure will build up in the lymph capillaries and push out on it, forcing the overlap to close. Then you also have mini valves, so when material is moving up, it can't fall back the other way. All right. So here would be mini valves here to show you right there. Here would be a lymphatic vessel. The endothelial cells kind of overlap, as you can see, and you can read this in the text. Okay, we'll go a little further. So here again, and these anchoring fibrils, I'm going to call them, here would be connective tissue. So when fluid builds up in the connective tissue, it would pull on this. Then these would slide open, and then material would go up into the lymphatic capillary. When the pressure inside here gets high, it'll push out and push the overlap close. So material can come in, but it essentially cannot go out. Okay. The lymphatic capillaries will come together and form collecting vessels. The collecting vessels have the three tunics. Now, we haven't studied the blood vessels. The same three tunics as really veins and arteries, which would be a tunica intima, media, and externa, 3 layers. They do have thinner walls and more internal valves than veins. Veins also need valves, so blood does not go back the wrong way. To anastomose means to come together. It's like several highways coming together. And so there are several coalescences, we should say, of the lymphatic vessels. They anastomose more frequently. Look that term up. Collecting vessels in the skin travel with superficial veins. They're surrounded by sheaths to travel with veins. And the deeper vessels, which are the larger, the deeper you go, the larger ones travel with arteries. With vessels, even blood vessels, sometimes you need a vessel to a vessel. Remember that the vessels themselves need to live. So they must have a blood supply themselves. They must have a blood supply. This is what we call a vessel to a vessel. Okay. Here would be an example you can study of the 3 tunics of a blood vessel, which would be similar to the lymphatic vessels. Okay. Right here shows the various lymphatic trunks. And so I'm going to start another YouTube starting here. Thank you.